students would now be focusing on designing them, programming them, making sure that you are receiving what you're expecting. I'll talk later about the tests that we then start doing. Then is assembly, integration, and testing. So after everyone has designed and developed their major components, we then have to connect all of this together so that they all speak to each other. And then we do a number of tests. Your functional tests, like the test that Pierre was talking about when they were asking about the images, how sure do we know that we will be getting what we will be getting. And on the third year, it's only then that we would then embark on doing your environmental test. We then leave the payload for the last year because it's the most crucial part of the satellite. So and it's not very easy, I have to say. I've joined the team, but it was just too much for me. I was like, I think I'm better off with the ATCS team. But then later I joined the AT team. So yeah, your payload, it actually defines the mission of the satellite. So everything in the bus supports the payload. So when you're designing your satellite, the first thing that you have to understand is the mission, what it is that your satellite has to do. Then you identify what payload has to go in there. Once you have the specifications of your payload, you can then only then design your bus, everything that will support that payload, because it's the payload that we want up in space. So yeah, everything else has to support it. So we do environmental tests as well. Next slide. I think I've got environmental facilities on there. Next slide. Okay, no. Okay. This is the bus, the platform. All the major components and subsystems I have spoken about. So can we go to the next slide with the, okay. This is just the phases, engineering phases, and all the engineers in this room would understand, so we can skip that as well. What is different though from, I don't want to say normal engineering, because space engineering is also normal engineering. What is different with us is that before everything else, we do what we call a demo model or a dummy model, where there are no electronics. It could even be a piece of wood or anything like that, just to see when we finally connect or integrate our satellite, if my hand would actually fit, I would be able to connect the harnessing. It's just the physical aspect of your satellite is very important. And then we have the engineering model. We start then including our electronics in that, although we do not do any environmental tests on them, just functional tests, so that we understand that our design is actually performing the performance of the design. And then your qualification model, you then start doing your environmental test there. Remember, you don't want to over-test your flight model, because you will be reducing the life expectancy of your satellite. So we do vigorous tests during our qualification models until we know that our components, everything that goes into a satellite, will be durable. It will be able to withstand the harsh environment in space and during the takeoff. Next slide. So somebody asked about the environment. How sure are we that our satellites would be able to withstand? I think the question was mostly about the harsh environment in space, because the environment that we are in is different from what your satellites would experience in space. So you want to do your environmental test so that you would know that your satellite would withstand the radiation, because temperatures in space are very extreme. If it's cold, it's extremely cold. If it's hot, it's extremely hot. So you want to do all those tests. So we have a climatic chamber that we use whilst we testing the major components. I mentioned that we start doing environmental tests at that level. Then we have the anechoic chamber where we do our EMC, your electromagnetic compatibility, because you want to ensure that your components will not interfere with each other, even within your satellite, and they will not even interfere with other satellites during launch. So your launch agency wants that report before they allow you to launch with them in their launch vehicle. We have the thermal vacuum chamber, and all of these facilities, by the way, we have them in South Africa. When I joined the space, the shaker, which is the vibration table, was the largest in the world when I first joined, but now the Chinese have overtaken us. They now have the best shaker. And we have all the X's, your X, oh, okay, I was still up there, your X, Y, and Z. I was still on the previous slide, but I guess it's okay. Anyway, so that vibration table, that's what I was talking about, that the Chinese have now overtaken us. They have the best shaker in the world. But ours are still good. We have 3 X's because during takeoff, so how do we get our satellites in the orbit? You all know that we have to integrate it to the rocket, and during the takeoff, there's extreme vibrations that the satellite would experience. So you want to test your satellite whilst it's still here. So if anything breaks, it has to break here, so that I can change. That, which is why we work with the mechanical guys as well, so that they would know what type of material would be durable. Also keeping in mind that the heavier the satellite, the more expensive it is. So what light material would be durable during these vibrations is something very important, and we get all of that from the mechanical guys. So everything in space is very important, even the nut or the bolt. It's a specific material, and how you torque it, it's also very imperative. If you tighten it too much, you may find that during your test, you find that you're not getting the results, that you're getting this too much noise and you don't understand what it is. You then have to unpack the whole thing and understand what it is. Sometimes you just find that there's just one loose bolt that is running loose and doing all of that. We have a thermal vacuum chamber as well. I mentioned that the environment in space is very harsh. When it's hot, it's too hot. And also, with the parameters that you set up, it's based on your orbital analysis. During your SMED lessons, you would learn how certain classes of satellites or where they should be rather parked based on the resolution as well that you're looking for. So there's a lot of work that goes into that. So based on the information that you already have, that, okay, there's a CubeSat or a microsat of this size, and it's going to be parked at this orbital slot, and these are the temperatures that it will be experiencing. You then set those in your thermal vacuum chamber. The vacuum is mostly for outgassing, because we still use your harnessing as your normal harnessing. Therefore, plastic outgassers. So whatever that outgasses has to outgas now, so that it does not land on your lenses, for instance, because it would just burn your lenses. So yeah, there's a number of environmental tests that we do. So that's a picture of our Sombandila test in the clean room. We can move from that. So who is Astrophica? So after this whole training, both my business partner and myself were awarded full-time contracts to work at Sun Space and Information Systems. So we worked at Sun Space and Information Systems until after the Sombandila launch. We continued there until Sun Space started having some constraints because we had an international client, and because of geopolitics, that project was discontinued and we started having financial constraints. A lot of people started saying, I mean, we've been trained. Why don't we start our own thing and see if we cannot rather focus on selling components or subsystems or even offer services. So the company that I was working for, Space Commercial Services, I think Temidayo mentioned it in his, okay, he's not there now, in his presentation, that SAS is one of the companies that are doing very well. So the company was focusing on assisting clients in building their satellite programs. So Sunspace was focusing on selling satellites, a complete satellite system. But then we saw a gap that you would find there are clients that are only interested in your ATCS components or just your services as a consultant, just to advise their guys. So fast track, we left Sunspace when it started having some constraints. I joined SAS, we worked with SAS, and we then later decided to start our own thing and focus on other sectors. But yeah, like I said, space followed us. Then we had our first contract from CPUT, Cape Peninsula University of Technology. They were building the ZACube 2 project. So they approached us and they said they need somebody to do the AIT and the project management of the project. They were running against schedule. So we then decided, okay, let us help them, because both Khaled and myself are AIT engineers. We specialize in assembly and the integration and the testing of the entire satellite system. So yeah, that's who Astrophica is. So when you see our combined experience of over 30 years, people are thinking, really, over 30 years has she, you know, does she have over 30 years of experience? I have 18 years of experience in space, and so does my business partner. But our team, you noticed that you know, most of the guys from South Africa started from the days of GreenSat. So some of the guys that we have in our company have been participating on those missions. So can we, next slide. Okay, yeah, Khalid said I should have these two pictures because I think this was a turning point for us as Astrophica, and it was our proud moment to be recognized by the President as one of the leading manufacturers and exporters in the country. I think Dr. Tandi mentioned that when you do this, you've got to think global, because as space people, we are global citizens. I cannot design or do anything specifically to cater for South Africa. South Africa is very small, but the globe is this big. Therefore, everything that we do, we have to focus on the global market. And I'm proud to say that we are so good that we got one of our contracts when we were bidding against the big companies like the Airbus. So that's how competent and good we are. There are a number of projects. If we go, next slides. So those are our interns. So when we were running our internship program, we had 29 interns, and the very first of its kind in South Africa, you saw with my team, it was just the 9 of us. So when we had 29 students, people were saying, Jessie, are you guys crazy or at such a big number? But we said to them, you know what, it's because we did not just recruit engineers and scientists, but we had marketing graduates there, we had HR students. So we wanted to show people that in space it's not just engineering and science. There's so much more to it if we are saying we want to sustain and grow what we're doing, because most of the companies, especially the upstream, are herded by just us technical people, and it's really not good. It's not serving us well. I'm sure you can pick up that Jess is also not a good marketer. So yeah, we do need to work with marketing people as well. You will notice that on on that slide, some of the pictures are blurred out because space is highly politicized. I was saying to Temi and Timani, space is so highly politicized that it's bad for us that I cannot talk about my international clients. I can proudly speak about all the South African satellites that I've worked on, but I cannot mention any of the international clients that we work on, because when they launch, it's a certain country's satellite. So they never mention that South Africans have worked on those. So we do get to mention some that are public knowledge, like some of NASA missions are flying South African components. The Chinese lunar mission, the satellite that is orbiting the moon and taking pictures, it is flying some of our components. We couldn't talk about those because those are public knowledge, but the rest of the projects that we work on, we can't sadly talk about them. So the CubeSat there, that's the ZyCube 2 that we worked on. That was the very first CubeSat that we've worked on. We were trained on microsats, so that was pretty new for us, and yeah, a bit scary, but yeah, it's really easier than the microsats, and cheaper as well to launch, cheaper to build, because it's small. So most of universities now focus on building CubeSats. So as Australica, we've also been involved not just on technical projects, but we've had our government asking us to assist research companies. So we were part of the technical team that built the industry development policy framework. Dr. McQuinja was still a space counselor at the time, and he was tasked to go through and oversee everything that we were delivering, if it is indeed what South Africa is looking for in terms of developing the industry. So whilst we were doing that industry development policy framework, for the very first time, for Khalid and myself, we got to know more about the downstream, because we are upstream guys. So for the very first time, we understood all the applications and the type of data that is received from this satellite. And that really opened our eyes, hence we then thought, let us team up with guys like Pilar who understand the downstream and the end users as well, so that when we design these satellites solutions, we know what problem is it really addressing. So after that successful industry development policy framework, we were asked to also develop an aerospace and space and defense master plan, which is a presidential initiative. So the president wanted to look at other sectors, and he was like, some of these sectors have a potential of bringing in more revenue into the country, but we are not really optimizing. So what it is that we need to do. So we were part of the technical team that worked on the aerospace and defense master plan as well, which is good for us because we're not researchers, so it was something new for us. So the market opportunity and commercial value gap. So this is the experience that we got while we were doing the industry development policy framework. So suddenly we learned that as engineers, gone are the days when we will just design a satellite and launch. After the launch, then we say to people, here's the data, see what you can do with it. Suddenly, just look at the market, understand what it is, understand what people need. So people say there is no money, but there is money because there is a need. So if you focus on the need, you will always be in business. So based on this research that we were doing, we then came up with a hyperspectral solution that we wanted to build for ourselves. It's not easy because we're not economists, we don't have any financial background with my partner. So just doing an exercise of understanding the market and developing a financial model, it's really not easy. So we are still on that journey. We are not there yet. I guess it's because we also focus on the side projects that we are working on, consulting, assisting with AIT and project management. Next slide. Oh, I need some water. So economic impact to South Africa. So when we were talking to some government officials, they mentioned that our solution should also cater for maritime solutions, because South Africa is experiencing a lot of hubs, and because they run in a very high speed. That's one of the reasons why our constellation has to provide 20-minute intervals in between, because you can't wait for a week for an overpass to detect. Thank you so much. Thank you. So, so your harmful algal blooms are part of the applications that we are also focusing on, because that's the request that we got from the client. Next slide, please. Climate smart agriculture. Pilar has spoken about that extensively, so I'm not going to go there. He's an expert in that. Can we go to the next slide? So expected products of our payload. These are the pictures that we have. These are actually simulations because we haven't launched yet. This is my last slide. Yeah, thank you so much. Thank you. Sorry, I'm shy. I saw yesterday somewhere we're taking the questions from there, so being a shy person, I thought it would be best to take them from there, so yeah, but it's okay.
It's okay.
I can go.
Yes,
thank you so much.
Thank you very much, Madam Jessie. Ladies and gentlemen, allow me to recognize the presence of our guest of honor, Mrs. Tandi Chisala Mvundula. She is the chairperson of the Malawi Space Agency Task Force. Madam, you are most welcome. Thank you once again, Jessie, for that wonderful presentation. Indeed, focusing on the need will keep our projects going. But yesterday, during Mr. Linden's presentation, he talked about the trends that have been going on in the satellite communication industry. But when we look at those trends, it translates to human capital as well. So I wanted to find out that what strategies can organizations use to adapt to changes in the skills and capabilities required for the future.
Maybe I should come back there. It doesn't work. Is it work? Oh, okay. So you've rightfully reiterated what I said about looking at the needs, addressing the needs first. So our strategy that we have seen that it works for us is specifically understanding the nation, and then get use of the free data. So, you know, what they were presenting yesterday is actually making my job very easy, because that's the strategy that I'm using in staying alive, because I cannot go and talk about data sets if no one has seen that. So if I team up with somebody like Pilar, who can say to people, there is free data, this is what we can do with it, but only there are gaps, because there are gaps. There'll forever be gaps. Life changes every time. When I was born or still growing up, we were not experiencing climate change. So our strategies have to align with the challenges that we're facing. And for us, we've picked up that working together with the government, it works for us, because no one is willing to take that risk in investing in space. But if your government is willing to support you to develop the technologies that would be used in helping, in enhancing the economies and saving lives, that is what we need as humankind. Saving lives is of utmost importance. Growing our economies is of utmost importance. I'm not sure if I've answered you, but our strategy is to not work in silos, but work with other professionals as well, and not just space, because space is a tool to addressing the needs. So I work with Pilar because he's a space professional, but we need somebody who doesn't have any space background. A farmer, for instance, doesn't have a space background, and they don't even care if the data is coming from a Chihuahua or anything of that sort. All they need is information that your crops are having some constraints. Look at it, you know, pay some attention to it. So working together and stop working in silos. And somebody spoke about the money yesterday. I can tell you now, now that I can mention this, you know, I am part of SANSA, I'm a board member of SANSA. So I got to understand the government more, you know, in terms of funding and all of that. And I learned that, you know, even while Sumbandile was built, there was no budget. All the other satellites that were launched by the government, I'm talking about the government satellites and not the private satellites, because there are a number of private satellites that I did not even talk about, you know, that I can even brag about when we're talking about the competency that we have in Africa, that we were part of a QB50 mission, and only 2 satellites from 24 nations, only 2 satellites survived, and those 2 satellites were South African satellites. So usually I mention that when I'm bragging, that as Africa, we're not just rich with mineral resources, but with human resources as well, because we're globally competent and we can do this. But we need to work together and understand what it is that we are doing. So we didn't have the budget as South Africans when we built these satellites, but our government said there is a budget in the agricultural department, there is a budget in the forestry and fisheries department, there is a budget in the education department. Why can't we go to these departments and say, you may not reap the benefits today, but if we start investing now, in ensuring that someday we will be able to have access to what we need, because there is free data, yes, but does it fully address all our needs? Somebody was talking about multi-cropping the other day. So before I even committed to developing the hyperspectral solution, I had to speak to Pilar because he understands that. So I spoke to Pilar. Pilar, do you think there's a need for this? Dr. McQuinja was like, Jesse, there's free data, come on. I don't see anybody wanting that. But Pilar said, Jesse, go forward. There is a need for this. So working together instead of silos, there is so much that we can achieve.
Thank you very much. So it's all about collaborative efforts. Thank you. Ladies and gentlemen, we now open the session for questions. Please raise your hand if you have any question or comment or observation that you would like to make. Yes, there is a hand there.
I wanted to find out, with all this launch of satellites, is there a way that you're actually like dividing space? Because at the end of the day, aren't you looking at clutter? I mean, yes, it's space, but there has to be a way that it's being allocated.
Yes, is there another question? Yes, there at the back.
Thank you for the wonderful presentation. Just out of curiosity, are all the parts of the satellites manufactured in SA? And since you're working with the government, say when you want to give data to security, is it offered for free or there is a cost attached to it?
Thank you. There was a hand there from Madam Chair. Can we have the microphone? Okay.
Thank you. Thank you very much, and congratulations, Jesse, on your excellent presentation. And it's very impressive, the work that you've done, and on being, particularly being a woman in this space. Hats off to you, and congratulations once again. I just wanted to make a note. I think there was a couple of points you made. One was on the collaboration. So basically, it's speaking to the need to work with people with soft skills. That's my understanding of what you were raising there, because sometimes in tech spaces, the solutions can be provided by the technology, but you need to have people that understand the systems who may not understand the technology's capability. So you need to be able to find a way to bridge that knowledge. I think that's the way that you get the best solutions coming through. That's just a comment, but as a question, you were mentioning the budgets. Sort of the different government sector budgets, and how you work with agriculture, forestry and fisheries and so on. I just wanted some additional information on how you work those collaborations, because in financing a space program, we would be interested in considering some sort of collaboration with different departments and ministries who need the information that the space agency would be able to provide as a method of providing sustainability. So looking at ways of finding sustainable finance, particularly in this space. Thank you.
Thank you very much. I think, Jesse, you can take those three questions. The first one, they are concerned about the environment or the clutter in space. And the second one, they are asking about the parts of the space that have been manufactured. Have they been manufactured in RIC? And another one is on budget from Madam. Thank you.
Thank you so much. The first question, I'm sure she was more concerned about the space debris. So I think when Lyndon was presenting yesterday, he touched on that. So for every microsat, for CubeSats, we don't have to have a d-orbital plan. But for every microsat that is launched, so for Sumbandila, for instance, if it was going to be launched today, it would have to have a d-orbital plan. Because once it has reached its life expectancy there, you don't want it just staying there for the sake of being there, because it causes more threats to other operational satellites, than it's serving us. So you have to have a d-orbital plan. We use the propulsion system. So the propulsion system we use for a number of reasons. For the micro sets, because they're bigger sets, people always say there is no G-force or gravitational force in space, but there is. It's actually very minimal, so it would take a very long time for the satellites to start deorbiting. So as it starts deorbiting, you use your propulsion system to push it back to its desired orbital slot. But once you have realized that it's now coming to its life expectancy, it's now nearing its end, you then deorbit it using the very same propulsion system to bring it back down to Earth. So that is now being addressed, which is a very good policy.
And just to get a clarification, is a deorbital plan one of the requirements
Yes.
before launch? Okay,
Yes.
thank you.
Yes, it is.
That our research
Can we get another mic at the front, please?
maybe it's better. There's a lot of research happening in terms of clearing up the debris in space, because there is already a lot of debris at this point. So whether we like it or not, there's a lot. So some people are actually looking at having a net to go and just pull out the debris. There's a research on that. Some people are looking at, I think, maybe having a process where you can refuel in space, so that, let's say, some of the satellites in MEO is at 10 years span. You can go and refuel it and take it to 20 years, so that you don't put another one and then to do that. So there is a number of projects that are happening to try and clear. I think there's going to be a lot more debris now with people like Elon Musk, who are putting 6,000 satellites in LEO, which is getting very crowded. Every university wants to send 10 CubeSats in there. It is becoming very things, and it's not easy to deorbit. The CubeSats, because they don't have whatever deorbiting plans and that. You just hope that one day they'll get tired, they will start coming slowly and they'll come down. So there are projects that people are looking at to go and start clearing. I think at Unicopus, somebody mentioned about the UN yesterday. At Unicopus, it's one of the major issues to look at clearing of space debris in space.
Thank you very much. Can we go to the answer for the second question?
So the second question, I think he was talking about free data for security, and then there was something about manufacturing. I'm sorry, I did not get the question there. I didn't understand. But in terms of free data for security, sure, Pila would be the right guy to advise on that. But free data, he mentioned yesterday that previously you would get it bi-weekly, but now you do get the free data weekly. So in terms of security, there's very little that you would do. I know even in South Africa, without disclosing a lot, we are working on a project just to look at this, because we are getting data daily to service our security needs, but it becomes a problem. I think somebody yesterday was talking about the privacy and all of that. We cannot protect ourselves from that, unfortunately, but if you do not own your space assets, and this is me as an engineer pushing my agenda now, it helps if you have your own assets, because you control the data. Whereas if you don't own these assets, and when you're asking for data for a specific area, you know, you would be getting questions like, what do you need it for? And I mean, this is your territory. You need to understand what is going on. And it becomes a problem because, you know, you do not own this data. So yeah. I actually liked what Dr. Tandy said yesterday about Africans being consumers of these technologies. And it's something that we are also in South Africa starting to address. As much as we appreciate that our government has invested in the HCD of these technologies, but we don't have our very own commercial satellite that we're receiving data from, which is a problem because we were talking about the small-scale farmers or subsistence farmers. How do they get access to this? Now, are we saying spaces for the elite, the commercial farmers that can afford to get this data whenever they need it? Is that it? The truth is no. Everybody, you know, has a right to this information. So if you have your own assets, you know, you can afford to give free data to your small-scale farmers, even if it's daily information that they need. Although I think in farming, it's not really necessary to get daily information. But I'm just saying, if you own your own space assets, you control the data because that's your asset. So yeah, in terms of the free data for security, I think yeah, you'll have to do with what is available, and if there are some challenges there because the supplier is not willing to give you that data because they're asking you, what do you need this for? Yeah. For the manufacturing, I did not understand the question, unless somebody else. And then the third question by Dr. Tandy, it was about the soft skills involvement, and I agree. It's just that in my presentation, I didn't have everything that we are working on as well. So Pila and myself are also part of a group that is developing the space curriculum for the high schools. So we are actually piggybacking on an initiative that had already started even before we got to know about it, an aerospace and aviation curriculum that has been approved. We're working with the Department of Basic Education and the University of Cape Town in developing these. So with this curriculum, we are addressing what you touched on yesterday, having vocational training as well, because we can't all be engineers and scientists. We need your technicians, your artisans, and you know, people that will do the maintenance, people that will do facilities management at Holtec. So there are a number of skills that could be developed from this. But you also asked how to collaborate with sister departments. How did we get it right in getting them to also co-fund the programs that we wanted? So I guess I will always make noise about understanding the need that you want to address. So before we even go to anybody, understand the need that you want to address. So if it's a political will, if it's coming from a president to support such programs, it makes it easy for the sister departments to say, yes, we acknowledge that we are using space. Some people are not even aware that they are using space every day. You go to the ATM, you're using space. So we can't shy away. We cannot be left out as Africans just because we are saying spaces for the elite, we don't have the funding, because we are making use of these technologies, and it is taking out of our resources pockets when in fact we could turn it around and develop this and start generating revenue for our continent instead of, you know, spending, because we are spending. The free data that we're saying is free, somebody is actually paying for it. So, you know, yeah, this is me again pushing for us, you know, collaborating and maybe as countries identifying what are the cross-cutting challenges that we're having, because it really would not help us if every country is sending their satellites in space. But if we collaborate, we will all say this is ours, therefore we all control it, we all have access to it. Yeah, so yeah, it has to come from the president.
Okay, so just to clarify on the question about manufacturing, I think he was referring to all those pictures of space projects that you presented there. They want to know that the parts of those space projects, were they manufactured in South Africa, or they were manufactured from somewhere and just assembled in South Africa?
That's a very good question. So as Rafika, I mentioned that we are an AIT company. We assemble, integrate, and test and verify the satellite. But all the components that goes into the satellite are manufactured, they're actually designed and manufactured in South Africa. The only components that we import are your batteries and your solar panel. And every time I say this, people laugh at me and say, you guys are developing these payloads and these ADCS components, but you're failing to... So we do design our power system, but manufacturing does not take place in South Africa, which is... I don't know why no one has looked into that. Dr. Makwinja has always been my case that, Jesse, why not looking into it? But yeah, it's something that maybe a company from Malawi will start manufacturing those batteries and solar panels for us, who knows. So yeah, we manufacture everything. Yeah. So South Africa has been in space for many years. You know, even since 1958, I'm sure Humbulani will touch on that. Since 1958, you know, when we started hosting the first satellite ground station. So we have been around, which is why we are in a position to do so much, you know, when it comes to satellites. Thank you.
Thank you very much. Can we have another hand? Okay, at the back there, please.
Thank you. I'm Amos Malonga. I was following, and very exciting that I've noticed a team of interns that were providing support, and the success of launching the satellites and all the work that you're doing. Just wanted to learn if you had TVET graduates or TVET students that were part of the team supporting the engineers when you were executing the programs, and also, if it's a yes, what were their major roles in the team? Thank you.
So thank you for the question. So for our internship program, unfortunately we were sponsored by MICT CETA, which had stringent requirements for the participation, and we couldn't, as much as we wanted to work with TVET colleges, which is something that we're still planning. It's something that we're still pushing, even with other companies, even with our government. We are having those discussions, but for our internship program, there were stringent requirements. They were funding the interns. So the 29 South African interns were sponsored by the MICT CETA, and the 8 American interns were sponsored by their government from the University of Illinois. So the funding was not coming from us, therefore we couldn't decide, you know, how to structure it. But it is a plan. It is something that we are discussing, as I was responding to what Dr. Thandi spoke about in terms of vocational training as well. It is something that we are working on. So most definitely we will, because we have, you know, some of the old ladies that I met when I joined Sunspace that are doing production, they don't even have engineering degrees. They are actually from the TVET college. So there is most definitely room and a role for TVET graduates to play, because when it comes to the production of these components as well, you need somebody that is trained. You need somebody, who has demonstrated that they are resilient, they are focused, and all of that. So TVET graduates would really fit. I mean, we do have them in the space sector. Most of the guys that are doing production are TVET graduates. So, yeah.
Wow, thank you very much, Madam Chesi. Ladies and gentlemen, let's give her a round of applause. My apologies, Madam has just raised her hand. Please go ahead, Madam.
Thank you very much. I think it's not for me. If they could just check in the online chat, because I think there are some questions coming in from there.
Yes, Tech Team, can you please assist us to have the chats online? There are some observations there. And there is another hand at the back. Please keep it raised so that they can see you.
I had one more question, sorry. My name is Navatanzi Malawi, and I wanted to ask, you were talking about debris in space. So I wanted to ask, how does that affect us environmentally? Because I thought maybe it would affect us in terms of maybe you'd have problems like with interference and also with all, because when you have debris, don't you have like other parts, if the satellite isn't being used, I'm assuming that other parts are also going to not be used and other parts might stray away, right? Because there's not enough gravitational field there. So I wanted to ask, how do you experience any environmental problems when you're putting another satellite up there, or do you experience environmental problems? Do we experience environmental problems here on Earth because there are a lot of satellites up there? Yes, thank you.
Challenges that we're having, partly, yes. But I mentioned that previously there were no regulations as to how do you bring back your satellite. And I can't say I wasn't a part of that because that was before my time, before I was even born. But as an engineer, I think Dr. Makwinja mentioned that there are programs that are currently running in trying to see how do we sweep the space in ensuring that we get the space debris. It has been going on for some time. The challenge is that how do you attract, the satellites? Just now you'd be attracting, operational satellites, but it's an ongoing research in ensuring that we clean the space. But to address the space debris, I mentioned that we now have a policy. We are regulated for every satellite that goes up. It has to have a deorbital plan. So it's not going to be part of the status quo of the non-operational satellites that are up in space. But, fortunately for the microsats that we're working on for low Earth orbit satellites, they re-enter Earth. Sombandila satellite that we launched in 2009, it re-entered, I think it was 2021. I couldn't be part of the celebration because I was not feeling well. So they do re-enter. It's your geostationary satellites that, would be a problem. But Dr. Makwinja has spoken about addressing that, because if it could be refueled, then we could, have them alive. As for the CubeSats, because they're very small, as they re-enter, they just burn out. So, yeah, we good. We do need space. We do need space. The challenges that we are facing, that you're talking about, the environmental changes or challenges, that we are facing, we do need space to even address those. I mean, the cars that we're driving every day when you go to work or when you go to school are also impacting on our environment, and we need space to address such so that we would know the carbon emissions and all of that, and identify those and come up with better solutions. So we do need space overall, and we can't shy away from it. Honestly, we cannot. We cannot. We've already started using it. Otherwise, let's just say we don't need space, and then we go back to the Stone Age. We don't use the ATMs. We don't use the cell phones. You don't look at your TV. You don't. So it's something that we have to embrace instead of being scared of. The more we are asking these questions and being involved, that would mean the engineers that are developing this would have these, concerns that you guys have in your mind. Be a part of it and not against it. Thank you.
Thank you very much. Tech team, can you please beam the comments, the online comments? Okay. I think we'll get those comments later. Ladies and gentlemen, please, can we have another round of applause for Ms. Jessie? Going on with our program, we are going to do a topic on space projects. We want to know how do we use satellite technology in disaster management and flood monitoring. I think this topic is one of our interesting topics as Malawians, because we're just coming from Cyclone Freddy that happened early this year, and we would like to learn a lot from this. Presenting this is Mr. Fila Siwanza. Mr. Fila, you're welcome.
Thank you very much. Good morning, everyone. Yesterday I enjoyed walking around. I wish I can get a mic so I can start moving around. My talk today is about the usage of satellites in flood modeling, mapping, and post-flood disaster mapping. I have examples of Malawi as a case study, and one of the things I will touch base on. Thank you. Yes. Now I can start moving around. Yes, so my talk will be on the usage of satellite data and information on disaster management, flood monitoring, a case study of Malawi. Can you go to the next slide? My talk will be on the sources of open source data. What I mean about that is that where do you get this free data that you can use to model floods? I'll also talk about cloud processing, which is the new direction we are taking in geospatial industry in terms of how do we engage with the data, how do we mine the data for valuable information. And I will also talk about the benefits of cloud processing versus working on your desktop. And I'll also talk about the free tools and softwares that can be used for flood modeling. And when I was reflecting last night about the talk I gave yesterday, I also realized that it's a reality that not everyone is going to be a coder. not everyone is going to engage with satellite data through the cloud because it needs an extra skill, which is programming. So I also need to talk about the softwares that still exist that can be used in terms of developing flood models. And then I'll also talk about damage assessment and risk analysis, and then also cloud processing platforms. I think that's a repetition. And then I'll conclude my talk, but within that, there are case studies of Malawi in terms of how all these processes have been used in detecting and monitoring flood situations in Malawi. So I didn't want to put up a lot of data custodians in this slide because you end up not knowing which data source is reliable. I've put up these three for a specific reasons. You have the USGS, which provides a number of satellite data. And you also have another part from the US, which is the Alaska Data Center. That one provides radar data, and I'll also speak about radar data for some of the audience that might not know what radar data is. I'll touch base on that. And you also have another platform which is called the EO browser, which is a European Space Agency's initiative in terms of distributing their data. So the EU developed quite a number of satellites, which are we call them the Sentinel series. It's a series because they developed a suite of satellites that are specific in addressing different applications. There is the Sentinel-1 satellite, which is an optical sensor. No, it is a radar sensor, my apologies. And then you have Sentinel-2, which is an optical sensor. I mentioned these two for this talk because these are the satellites that are widely used when it comes to modeling floods, and also because of their resolution. Both of these satellites are a constellation, which means that in Sentinel-1, there is Sentinel-1A and Sentinel-1B. Yesterday, I spoke about the improved revisiting time of the satellite. When Sentinel-1 was launched, you could get one image every 14 days. Now, an identical satellite was also launched, which was called Sentinel-1B. So when Sentinel-1B was launched, the 14 days revisiting time was halved into 7 days, which improves your acquisition time. But most importantly is that Sentinel-1 has a spatial resolution of 10 meters, which is relatively good for a number of applications. And in this case, flooding is very much applicable in flooding. However, as an optical sensor, it cannot see through the clouds. I mean, as a radar sensor, which is Sentinel-1, it has the capability to see through the clouds, right? And then, which is the reason why Sentinel-1 is perfect for flood monitoring, because in the case of the floods, you also like to see the flood extent so you can map it and identify the places and areas that are affected by the floods. And then you have Sentinel-2, which is also a constellation, Sentinel-2A and Sentinel-2B. Their revisiting time is also 7 days, because as one satellite passes over, the other satellites will follow after 7 days, improving the revisiting time. Now, Sentinel-2, as much as it is an optical sensor, it is very important in post-disaster analysis in terms of identifying the areas that have been affected by the floods, and also identifying certain resources that might have been affected by the floods, such as the roads and the bridges and other infrastructure that might have been affected by the floods. They're also very important. And you also have the Landsat series data. Landsat 7, Landsat 8, and also Landsat 9. Landsat 7, Landsat 8 and Landsat 7 are also a constellation. With Landsat 7, however, there were technical glitches because some of the bands, they have what you call lines and strips. So you need to post-process them to remove the line stripping. I'm not sure if they were able to remove that, but to my knowledge, that has never been successful. Hence, they launched Landsat 8 much quicker than they would have liked because Landsat 7 hadn't reached its lifespan on space. They had to speed up the launch of Landsat 8. Then you have MODIS, which is a satellite that has 1 kilometer resolution. It is good enough to look at wide areas when you're looking at a national level when it comes to Malawi, because one image of MODIS can cover the entire Malawi country. South Africa, you need 2 MODIS images to cover the entire country. So if you're looking at large scale or a wide area, MODIS also becomes critical. But the most important thing with MODIS is its spectral resolution. It has about 36 spectral bands where you have a number of information that you can pick up using that sensor. And the other critical data that is very much important in flood modeling is the digital elevation model. There are also different resolutions. You have the 90-meter resolution, and you also have the 30-meter resolutions, digital elevation model, and they're all for free. You have the SRTM digital elevation model, which was developed by the US, and then you also have the ALOS 30-meter digital elevation model developed by the Chinese. And the other part that I want to talk about is the LiDAR. LiDAR normally gets acquired by private projects. Some of them are also government funded. The reason why I also put it there is because there are a number of projects funded by government that are procured to get LiDAR data. And I'll go back to the point I made yesterday of opening up, because once you have access to LiDAR data, you'll be able to develop high resolution digital elevation models, which are very critical in flood modeling. Because with the 30-meter digital elevation model, when you're modeling floods, there's a lot that happens between every 30 meter in terms of elevation. So if you use LiDAR, you are able to develop and get high resolution digital elevation model, which improves your flood modeling. So the better the quality of the data, the more improved the results that you're going to get. So we should also aspire to get the highest resolution data that we can lay our hands on when we are modeling floods. Can I go to the next slide? And then, apart from satellite data that we also use during flood modeling, you also need climate data. Because at the end of the day, as much as you need the satellite data, you also need rainfall data, you also need temperature data, you need runoff data, you also need subsurface runoff data, you need evapotranspiration data. These are the sources that I've found together with my colleagues that we've been using in the academic space, and we've produced a number of publications on this data, and it has worked very well. And these sources of data is widely used in the research space, and it is easily accessible. There is MDATE, which is the International Disaster Database. It keeps a lot of disaster data for every country across the globe. I got Malawi, flood data from that source, and it returned about 36 flood events from Malawi since 1965. So that data is freely available online, which is very much critical when you are modeling floods, because as you are studying the rainfall and temperature trends from the past, you'd also like to know which of those high rainfall events led to flooding. But if you don't have that data, you won't be able to be certain that the spikes that you see in the rainfall, did they actually lead into a flood event? So you can correlate the two. The actual flood recorded on the ground versus the rainfall data that you are getting. And then you also have the Flood Observatory Center, which also is another repository for flood events that have been recorded across the globe. On the other side, you also have the power. The top one, it is the NASA Power Data Depository. It also provides long-term climate data from 1940 up until presently. And that data is also critical in terms of modeling, because for you to be able to use machine learning, you need a lot of historical data to train your models about the environmental conditions in the past, so that you can be able to predict what's going to happen in the future. So you need that long-term data. The more long-term data you have, the more your models will be able to acclimatize to the conditions of the past and projecting what's going to happen in the future. So all of these data sets are now freely available. And the other one, it is from the European Copernicus program, the ER5 data, which also provides quite a number of climate parameters that are also valuable when it comes to flood modeling. So for those that are interested in flood modeling, these are the sources of climate data that are reliable, and the data is free of charge. Some of these data, they have been post-processed, because you don't just get rainfall data, you get runoff data, you get soil moisture data, you also get surface runoff data. So you are able to mine these different data to get to the actual decision that you like to make, because I made an example error that says, if you have a spike in rainfall, you would ideally think that so much rainfall would lead into a flooding. But when you look at the flood data, there's no recorded event of a flood. Then you ask yourself, why is that possible? Then you need to pull in the surface runoff data. Once you pull up the surface runoff data, you realize that no, there was so much rainfall, but the surface runoff data tells me that there was not enough surface runoff that could have led to a flooding. Then it means that the soil actually took up most of the rain. Then you're able to fill up those gaps and understand and feed all of that information into your model, because it can also bring the question of the seasonality of the data. Was it the winter season? Was it the summer season that led to that scenario? So all of this information is critical in building models that will be always coming to a situation where it is more or less like realistic, because as we are building models, they'll never be realistic, but they try to create a situation where they simulate real life situation. That's why you always have to improve on the models. Thank you. So now that you have all of this information and the data sets, how do you then mine this data to develop your models? Yesterday I spoke about cloud processing, but I also realized that I also need to talk about desktop applications and softwares that can be used or that are widely used in flood modeling. You have HackRAS or HackHMS, which is also a widely used software that is used for flood modeling that also uses a lot of climate data. And you also have TerraHydro. TerraHydro, it's a software that has been developed by the Brazilian Space Agency, focusing on flood modeling. For those of you in the room that are hydrologists or develop flood models, these guys at TerraHydro, they were the ones that came up with the product that we call the height above nearest drainage. In short, we call it the HAND. The HAND has been proven to be a model that is relatively accurate in identifying flood risk areas. They call it the bucket system. And what is the bucket system when it comes to flood modeling? It's a situation where if you don't have enough data to simulate flooding, what do is that you just pour water in a basin, and it doesn't matter the conditions within that basin. A flood always starts from the bottom, moving up. Water will always start from the river channel and then flows upwards. So the HAND model was developed on those bases to say, if we have a basin and we fill up water, if the water is 1 meter above the basin, where is the flood line for 1 meter? Where's the flood line for 2 meters? Where's the flood line for 3 meters? And to develop that model, you only just need the digital elevation model. So in the absence of other climate data, the HAND product has been proven to be relatively good to simulate and identify flood lines. Then you have QGIS and CRAS. These are open source softwares. And one thing good about QGIS is that it has plugins which are constantly being improved by developers in the community of geospatial. So it is also another tool that can be used to develop flood models and leveraging on the plugins that are constantly being developed and introduced within the QGIS platform. And then you have SNAP, which is the Sentinel application platform, specifically developed for the Sentinel suite of satellites, which is relatively a good software when you are using Sentinel, when you want to use Sentinel-1 data to identify your flood lines and your your flooded areas. Then you also have InnerSafe. InnerSafe, I've put it separately as a risk analysis tool. It is a plugin within QGIS that is used for risk analysis in terms of post-flood analysis, identifying areas that have been affected by the floods and identifying communities and infrastructure that have been affected by the floods. So InnerSafe, it's a plugin for QGIS, but its specific task is for risk analysis. And then, once again, the cloud processing platforms, I spoke in depth about them yesterday, so I won't say much about them, but they also very critical when it comes to developing flood models, because there are existing codes and scripts and resources online that are easily available to model floods. And this is one of the cloud processing platforms that I spoke about, where I ran a model to look at the rainfall and runoff situation within the